here's a small update of the progress, and it is indeed a progress which I'm very happy about it because you'll see in a second. If I'm pressing this button, you see this button here, you see it will count and stop to number 4 as I set it there, or 5. No, it's 4. That one is. Let's set it. Actually, let me slow it down a little bit and press it again. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, so let's count to 8. This is reset to 0. When I'm switching there is starting to count, but then it's stopping, and when I'm pressing it, 2, 3, 4, 5, 6, 7, 8, and stop. I'm not doing it all the time, but if as you can see, I override, or I hacked this module that I have here. I've dragged this long ass wire from its output of that 4 input that I have right now. It's a 4 input NAND gate plus a NOT gate module, this little module, and its output is this wire here, but it's also that wire, that blue wire that is going here, and then is going underneath to pin 3 to 74, which is a flip-flop. And here I have also D-type, DTFF, D-type flip-flop, also 74, the same as that one that is there. And I've also linked to pin 3, as you can see, this yellow wire. And pretty much this is what it's doing. I mean, if I'm taking this output from there and putting it where here, directly on the wire, if I'm making it work automatically, which when I'm switching this wire here, you will see these two LEDs works in parallel. Depends. Let me reset it like this. This is the reset. Yeah, it's a bit complicated subject because it's still there are a lot of I had to play quite a while to get it. But you can see they are synchronous in the same time. Whereas those two the same output is going to the same inputs directly on the inputs of these two chips here, and they flip flop together synchronously. All right. Let me switch back from automatic to manual, which is there, and from here to the input of this 7404, which is a NOT gate, and plus a resistor. So I choose an input and an output. Actually, you can see it here how it looks. 7404 is that is 9. Pin 9 is input, and pin 8 is the output. And pretty much this is what I put here. I don't have the circuit diagram to show you exactly how this works, but you should. It's quite simple, really. How I'm showing you this. Actually, this flip flop here is the same copy of this flip flop here, plus the LED. The capacitors and the resistor 10 kilo for the LED, or whatever LED resistance you need to put there, and the same wiring is exactly this small module here is a copy here, and here is a NOT plus a button, a couple of resistors, and pin and a connection to the pin 3. And this signal, instead of going directly to that pin 3, is going to all of this NOT plus this button and a couple of resistors. I'm calling them buffering resistors. They are not keeping anything, but they are helping smoothing operation, especially for this. It's like a debouncer, especially these two resistors here, which they form is 1 kilo, but is actually a 500 ohms there, and it's smoothing the clicking operation. Usually you need a debouncer circuit like I'm having here. I actually tested it, and it's another problem with this guy that I have here. It's very good, it's actually working, but I need an inverse debouncing button. As you can see there, I actually draw what it's doing is maintaining a negative on this white wire, and when I'm clicking is giving me a positive pulse for a couple of milliseconds, I think 100 milliseconds or something, and then is getting back to negative. What I need an inverse pulse, staying on the high, then going to low when it is pressed, the button is pressed, and then going back to high. So that's I really don't want to do it because yeah. So I kind of managed to debounce this button using a simple 500 ohms to the ground, to the negative rail here, instead of a direct link, which I was using until recently. And then I said let's drop the current a little bit, and it helped immensely because when I was pressing, sometimes was switching, sometimes was not switching because of that debouncing problem. But with this simple arrangement that I have here, perhaps it's almost working on one press. And as you can see, hopefully, now I press it and it's running. I set it to 8, but it is actually working to everything. So if I'm pressing again, you see, I'm pressing only once and it's already working. Sometimes it's giving me slightly errors, but probably I'm touching something there that shouldn't be touched. But you see, is very close to a debounce, very close to a debounced button. I strongly believe it's because of this input here. That input is very sensitive to bouncing stuff, and this is like I said, like a buffer, like a helper. It's very cool. It's very cool. I'm very happy that I found this solution here for this button because it was all jumpy all the time. Trust me, this is a scrapped and used button and is not good. It's not new and it's very old and it's very bouncy. It's way too bouncy. So the idea for this, what I did here, let me actually switch to 16 here. But I've seen an error already. One second. Let's talk about something else first. So when I'm pressing this button, I'm seeing this LED on, and when the switching is turning off, all the time is the same. So when it's functioning while it's counting, it's staying on. You see, it's staying on all the time, and then it's switching off instead of being in parallel with that one as it was before when I put the wire directly in parallel. It's because of this arrangement that I have here. I believe is a reading. You see, it's pulsating. If I'm pressing it, you see it's a little bit pulsating. That's because my guess it is actually receiving the very small impulses from that output, and is kind of filtering. This is kind of a filter, and that is actually switching on off very quickly. Probably, I'm not sure what is going on, but either is an error. It should switch on and off exactly like that one. That's one problem, but it's a minor problem that I can get over it because the entire circuit is doing exactly what I want it to do. So only because it's not actually switching in parallel with that one is not really a big problem. Oh, well, let's jump to 16. So now when I'm pressing this button, it will start to count to 16. But you see that this is also staying on all the time the counting is performing. So it's like a hint, you know. It's interesting. It's interesting. But that is not switching correctly when I switch to 16, only to 16. It's actually switching on whatever permutation I have there. It's also not a big problem. It was nice if it was not switching on whatever I had there. Let me press again. Actually, I give it a test and I switch it all on to 15. So all of these switches, I move them to positive, to connection mode. They made a connection, and this is like counting to 15. And then when I switch it here to 16, it actually lit the first LED as counting to 16. But when it's not switched to 16, when it's switched to 1 to 15 here, it's not letting that last LED. So it's counting only to the third and then resetting. And yeah, it's a bit of let me play it again. So now it's to 16. It will lit the last LED there as well. But when I'm switching to 15, also you can see it here in binary, but oh, it's not set to 15, it's set to 8. I was scared for I shit my pants a little bit because I don't like errors, and this was a big error if it was an error, but it's not. I had to put them all to, so now they are to 15 set to 15. Let's press it again, and now also see until the second there, and that's it. And if you looked here, the last one didn't lit. Let's play it again. Come on, and the last one didn't. Let me actually lower the speed a little bit to actually show you, because this will be fast in my final video. And 3 and reset because it's 15, and the last one didn't lit. But if I'm switching to 16 right now and start again, right? And yeah, let's wait it a little bit, and you will see all 4 of them will lit on 16. So they are all 4, and also switch that flip-flop. So that's a little bit of an error that I have. To switch this flip-flop on whatever I have there, I have to actually switch them all to 15 to actually switch that one. But it's not really a big deal. It's not really a big deal. Let me switch them back to, actually, let me cover it and put my hand here and switch them all, these 3. Right, and I leave only that one, which is the 8. And now they are counting. 7 and 8 is resetting. So this is what I did here. This is, as you can see, this is on a breadboard for testing, of course. But very, very quickly, today or tomorrow, I'll build this module as well and attach it here, probably in continuation of this one, another drawer like that, like this one. And I will add this continuous and stopping mode. These are 2 modes. And I think these are the 2 modes, continuous and stopping. But also I want to test forward and reverse modes for the motors. But until then, I'm not sure if I will jump directly and build this at the moment. I want to test something else more complicated in continuation of this to have a larger or bigger board. Or I don't know. We will see. Actually, another thing is I can skip this entire circuit that I have here, and 474 flip-flop is having actually 2 flip-flops inside it, and I'm only using one of them, the left side, but the right side, as you can see, is not used. So I can use theoretically the right side for this thing to actually to reset and to make the switch between resetting between continuous working. Let me actually show you how is continuous like that, and speed it up because it's set to 9. It's taking a while, but see, yeah, it's I have to reset it like that. And yeah, now they are working synchronously, as you can see. This is by itself, is doing it by itself without me pressing that button. And theoretically, like I said, I can drag some wires and use that secondary flip-flop that is having inside it. That right side is, I didn't think of it, I will use it. I didn't left any tolerances for a new circuit using it. I don't know, I really don't know if I should use it or not. I think it's much more easy to use another one. It's not a, yeah, it is always it is a problem of space, but I don't know. That's an idea, you know. On this NOT gate, I can use a resistor because I only need one single NOT gate, and not four of them, like no, 6 of them, like it's having inside. You know, I don't really need all of this, and I only need one single module of a NOT, and I can do it from transistors, scrapped transistors as well. It's my idea. It's my idea how to continue it, but we will see. But these are the main ideas, and yeah, so I'm really happy about it. Do you like this this nice wiring that I have here? I also had to. I'm not sure if you can see it, right? You can see that resistor how is only with one leg soldered there, and the other side is to this wire here. That's how I had to take out everything from the cardboard. This electronic boards that I have, I took them out from that to actually desolder from this side, because from this side I couldn't reach it. I was melting something, and then I had to take it out and put it back in, and it's still working, still working. It's very fragile, it's extremely fragile. If I'm trembling it a little bit more harder, something will get loose, and I don't want that. But so far so good. All right, this is it for now, and we'll see later how it will. I like that it is hackable. That's a very important thing, you know, to be able to hack and continue to progress and make the entire board more customizable. You know, you can customize it and add to it like I'm trying right now. Actually, I succeeded as well. So pretty much this is it. Thank you very much, and see you later. Bye bye. Hello. So this is the circuit that I couldn't show in reality, because in reality I have to print it on paper, and my printer is not that good anymore. And also I've managed, after years and years, I managed to get a smartphone that I can call it mine, and I uploaded this image on the phone, and I can zoom in and work with that from directly from the phone screen, and not from the paper as I'm usually doing it. And here it is what I'm having, but it's much more is better for you to see it on the paper and directly there in reality with the circuit. But pretty much this is it. This is the wire that is coming out from this NAND plus NOT module. That blue wire that came out from there was intersecting already this thing that was on that circuit board, and then I drag it, I continue it after that. I actually took it from here, but as you can see, in this point is a short between all these wires here, so it doesn't matter from where I drag the wire. So I drag it from this point to the breadboard and pass it through a NOT gate, and then I was getting at this part where I use 1 kilo in reality, but here in the simulator I have to use other values because it is only working in a certain way. But in reality I use 1 kilo and 500 ohms resistance around this button. Make abstraction of this button because this was for testings, for other testings, that is not included here in this circuit. And this was the actual button that I used. Here in the simulator is working fine without this resistor here, so directly linked to the ground. But in reality it gave me some errors from the button itself and to the input of this chip here. And that was kind of resolved like a debouncer, like a buffer here, that helped this button perform a little bit better when pressed in reality. So this was a nice trick to add there. I got lucky pretty much with it because I am testing and trying different permutations. This is the actual switch between continuous and between step here. And let's play it a little bit. Let's run it. So now it's running. Actually, I have to reset this counter because it's counting 1 by default. I have to reset it to 0. It is set to 8. I know it's hard to understand everything, but follow with me along. So this 1, 2, 3 are disconnected, but only this guy here is making a connection. This is connected. So this is for number 8. Actually, it will count to number 8. Of course, I can change whatever I want if I want, but so far it's good enough for number 8 to count. It is set as a step right now. As you can see, nothing is moving, nothing is counting. But when I'm pressing this button, you will see everything is running until 8. I know it's hard to see, but this is an 8. And next it will be a 16. And 16 there. Also pay attention here on these LEDs and also on the binary, but also here it will stop at 7 and then go back to 0. Let's press it again. So it will go a little bit fast, but you see, and it's resetting to 0, which is absolutely super good. This is my switch from 1 to 15 and to 16 only. So now I switch it to 16 only, and now it will go to this number 15 and switch back to 0 as the 16th. And I press it again, and it's running absolutely fine and stop. So it's performing one run, and then when it is getting that reset impulse, it's stopping. And this is exactly what I did here. That was my intention actually. And here is continuous, and it's doing the thing by itself. It's running to infinite, and it's doing it all right. It's doing correctly. Let's switch to 8. It will count only to 7, and on the 8 it will reset. And pretty much this is it. This very important switch I've added here. I've also added in Proteus circuit. I stopped the simulation right now. I've added in the Proteus circuit. Before I was having an automatic impulse generator here, frequency generator. But I've actually built the circuit that I have there. So if I want it to be to count more fast or more slow, I have to change this potentiometer exactly as I'm doing it from reality. and this is the logic pretty much what you've seen there. And next, I will have to make these two guys here that will come out from all of this thing. So check it out how big it is. And it will switch from turning left to turning right, the motor. And this switch will actually power the IC in reality. But here in the simulator, I don't have that function, unfortunately, and it's very, very unfortunate, and it's very bad that they didn't include it to actually switch off the power of the chip, and like a pin, you know. But I have to use this contraption here, this dip switches, these two dip switches. I have to switch them to actually switch from one to another, from one chip to another chip. But in reality, I will not put these dip switches. I will only power or unpower the chip itself, and it will count ascendant or descendant, depends depending on the wiring that I'm having here. You see this this wiring that is not selected. Okay, so one is having the wiring normally, and the other one is having the wiring inversed. So that's what is making the switching forward and backwards. So pretty much this is it, and I hope you like it. And this is it. Thank you very much.